Hello and welcome back to Let's Code Physics. Last time we were successfully able to have our two cars on a loop identify when one of them is in front of the other one, meaning when one of them is along each other's center line. So what you see here, we've got this lighter gray center line for the faster moving car, this darker gray center line for the faster moving car, and they are looking along that center, each of those center lines. So they're looking along each of these rays shooting out. And once they find a car that is in their lane, then they give us a message, car in front, because then they know that there's a car in front of them. But right now they're still not doing anything with that information because this car is moving twice as fast as this one, and it feels no impetus to slow down because we haven't told it, boom, to slow down yet. So that's our goal for today. Is to get the faster move, is to get each car to evaluate whether the other one is moving slower than it is. So let's see here. We have been using this Boolean car in front to indicate whether there's a car in front and whether we need to be slowing down. I suppose for completeness we should define a new Boolean for do I need to slow down. So let's call this one bool slow down. Let's originally have it be false, just so that way we can default to that. Although I suppose for safety's sake we should default that to true, shouldn't we? Either way, we'll override it in just a second. So what we need to do now is we need to compare the speeds of the two cars, which means I need to be able to get the other car's velocity. So let's see. We called that thing the hit information, and that's been stored here, so I can still access that. So I'm going to need its rigid body. So I'm going to need to define a rigid body. Let's call it. Do I already have an other car defined? I don't think so. Rigid body other car, and we'll say that other car is equal to hit dot let's see, I want that to be no, excuse me, I need that to be get component. There we go. Rigid body. Go. Oh, and I need that to be a dot at the end of the thing. Okay, so I need to follow my example from up here. So I'll just copy this and paste this. There we go. So now the other car, I guess we need to call this other car rigid body. Right, so I need to declare it as such. All right. So now we're going to evaluate the two cars' velocities. So we'll say that slow down is equal to, and let's see, so we do need to slow down if the other car RB.velocity.magnitude and our magnitude. Now I have declared our car's rigid body somewhere. Okay, I've just called that RB. Okay. Let's see. Let's scroll down. Here we go. Okay, so that needs to be less than RB.velocity.magnitude. Cool. And let's have it print out a message of I need to slow down. Cool. So that should only appear now for the faster moving car. That should not appear for the slower moving car. So let's see if we get that message as we expect. Object reference not set blah blah blah. Let's see, we have a problem at line 154. Alright, what did I do wrong here? Component rigid body. All right, how did I get my own rigid body? It was get component rigid body. Okay, rigid body other car RB hit dot collider dot game object. That's how I got this thing's which lane here. Doesn't like it at 154. Okay. Do I need to... Alright, let me look into this and I'll cut here and then I'll be back. Oh, so I need to have this be under if there's a car in front. Because otherwise there's no car for it to look for. That would be why I had that comment indented, isn't it? Okay. Good job, Brian. There we go. Alright, let's try that again. Okay, cool. Car in front, and one of them is saying I need to slow down. Okay, awesome. I'm a little bit... an equal number of those, because... Oh, right, because this one doesn't see the car in front. Okay, so maybe this one hasn't seen the car in front yet. Okay, so this guy's saying that he needs to slow down. Awesome. He doesn't necessarily need to slow down at that point, though, because it's also a matter of how close they are, right? Because if the faster moving car is sufficiently far away from the slower moving car, then it doesn't necessarily need to slow down. So that's our next part, is whether we are too close to the car. So let's do this. Let's put all of this under here, and we'll say if slowdown is necessary, then what we'll need to do is we'll need to evaluate whether we are too close to the car. So that's not simply a matter of taking the distance between the two. We need to take the arc length along the center line. So let's see about that. So what I need to do is I need to find out where that... I need to recall where that car is along the center line. So in other words, I need to get the arc length distance from this point along to this point on the center line, right? So I need to store which index the center line point is here, where I was able to see the car. So let's see. So I've declared int I point here. Why don't we call that? Let's declare another int as car point. This is just so that I can save it, because I might not remember what I point means, but I will remember what car point means. So this is going to be where we store location of car in car point. Let's see here. So we've got car in front, etc., etc. So let's see. So this is where we have found the car. So I need to store car point here. So we will have an encounter at car point. Thank you. So let's see. So we'll scroll down here. I need to look for the distance now. Okay. So let's say that we've got float. Do I already have a distance declared? I don't think so. Distance equals 0. Cool. And basically what we'll do now is we'll loop over from 0 to car point. So let's do for int I equal to, we gotta start that at 0. We need I less than or equal to car point. We need to increment I. And so what we'll do is we'll say distance gets added to, we want this to be the distance between successive points. So this needs to be, center line of I minus center line of I minus 1, because it needs to be the next one minus the previous one. So what that means is this thing needs to start at 1, and actually I need to start this at the transform position. So I need to start at transform.position minus, or actually let's go with, let's see, so we'll need to go with center line of 0 minus transform dot position, because this point is always going to be ahead of this point. And actually I need to turn these into scalars, don't I? So that needs to become a distance. Oh yeah, the easier way to do this is vector3 dot distance. This is a handy function I discovered. It evaluates the distance between 2 points, so it takes one minus the other and takes the magnitude. It's wonderful. Vector3 dot distance, center line of I, comma center line I minus 1. All that subtraction won't cancel out because we're taking the magnitude, because if you imagine all these points along here, we're taking this distance plus this distance plus this distance, basically. Alright, cool. So we've got for int I equals 1, blah, blah, blah. Okay, cool. So now what we need to evaluate is whether we are too close to the car. I guess I need to move this comment up here. Am I too close to this car? And so what we're going to do now is we're going to compare this distance to our stopping distance, which is not a variable I've defined yet, so I'll need to do that up above. Let's see. So what we're looking for now is going to be slow down equals whether the distance is less than or equal to the stopping distance. Now obviously that's going to need some kind of safety factor associated with it, but I'll tweak that a little bit off camera. And so obviously we'll need to tweak the stopping distance a little bit to have a safety factor. So it would be the actual stopping distance, plus 10% or something. And obviously that's going to depend on, our brakes. It's going to depend on our current speed, etc. But for right now, we'll just have that be a constant. So I need to define stopping distance. Why don't we make that a something that's accessible throughout the code? So let's call private stopping distance. And right now, let's just make that. Why don't we make that several car lengths? So I've got my length right here is the car length, and so we'll have stopping. Where do I not get stop? Oh, private. I can remember to declare private or float, but I can never remember to declare both. So let's have stopping distance equals. Let's see. How many car lengths are you supposed? I know it's supposed to be the so many second rule, but they also give you car lengths. So let's say 5 car lengths. 5 times my length. And we'll just, this is not driving advice. This is just a number for us to test this out. I'll put in the actual, stopping point later. I am missing a... Okay, right, I'm not done with this part yet. Let's see here. So we've got a slowdown of... Okay, so we've got we're evaluating whether we need to slow down. Cool. And so, let's see, we are done with that part. Now I need to be done with that conditional. Great. So our last part is to just decrease the car's speed. So if we need to slow down, I need to be able to access that Boolean outside of there. So let's cut and paste that up here. What went wrong with my rigid body here? Max distance expecting something. Getting an error on line 180. Oh, probably because I haven't closed up the right stuff. Okay, so let's see here. Yeah, that's closed up. I'm not sure why I'm getting a red line on there, but it's not giving me a compiler error. All right, so anyway, if we need to slow down, so this is now the final slowdown. The way we'll do this is we'll add a force to the car. We'll do, let's see, so for that you do rb dot add force, and now we just provide a vector. So what we'll do is we'll have a braking force, so I'll need to define that, times, let's see here, we'll need to do let's see, I defined earlier a thing called car hat that keeps track of what direction the car is pointing in. And so all I need to do is have that be in the negative car hat direction. So I need this to be negative braking force times car hat. Cool. And obviously I'll need to also add in the car's ability to speed back up when necessary. So let's see here. So we'll have this be brake to match speed in front of car. Actually, that should go here, shouldn't it? There we go. So now I just need to define braking force. Let's put that under stopping distance, private float, braking force. Let's have that be 1. I know I need to actually do the kinematics there to figure that out. Let's see, I need to close up my conditional down here. Let's see. So I've got that part. I am closing up my determine goal. Okay, good. All my compiler errors run away. So let's see if our car slows down. All right. Oh, shoot. You know what? That's actually not going to... That adding force is not going to work because the way I have the car moving is I'm directly setting its velocity. If I go down here to move car, what I'm doing is I'm directly setting its velocity based on its speed limit factor. So what I need to do, instead of doing the built-in add force, I need to adjust speed limit factor. So speed limit factor needs to be decreased by the braking force times time dot delta time. I think you want fixed delta time there because we're in a fixed update, if I remember correctly. There we go. I can always change it to delta time. All right. So let's see what we get here. Okay, so let's take a look at our faster moving car. Which one is our faster moving car? Is this one? I believe that's car 1. Let's check the in the scene. Yeah, so this is our faster moving car. So what we should see... no, that's our slower moving car, excuse me. Car is our fast moving car. Okay, so what we should see is we should see the speed limit factor decrease once it comes around and sees the car and starts to brake. Or maybe it doesn't show that here. I guess that's just for setting. I guess that doesn't update it. It does look like it's slowing down. Oh, there it goes. Okay, yep, there we go. So it has slowed down to just below this car's speed. So it saw that the car was in front. It saw that the car was going more slowly. So it decreased its speed a little bit each frame until it came to match this car's speed. Now, actually, it's a little bit under this car's speed, right? Which is fine. So we probably need to set up some kind of, tolerance for it or something. So that if this car... were to get faster, we want this car to be able to increase in speed as well. But I think we'll put that adjustment in next time, and then we'll make our slower moving car behave a little bit more interestingly. We'll have its speed vary sinusoidally, and then we'll see if this car varies sinusoidally to match based on the algorithm that we create. So this has been a really big success. We are avoiding traffic collisions. That is always a good day. I hope you have a great day and avoid any collisions. I will see you next time. Bye-bye.